of SQL statements and joins. Okay. So as we have been doing the SQL part, right, the select queries which we have been doing from 2 days past, right? So the SQL, what we are doing is it's called a structured query language, and this comes in the part of your non-procedure language, because if you understand the difference between procedure and non-procedure, so in the non-procedure always we concentrate on what you want, not it doesn't specify the process of attaining it, nothing, but we just write a query to get fetch the data. We don't know internally how your query fetches the data, right? So that's the difference here. Okay. And actually, the SQL is a standard, like most of the companies, there are different vendors of the database, right? So if you consider any database, always, like most of the times your SQL queries, the queries which you write in one of the database will work in this other database also. Nothing but your select statement, from clause, where clause, most of the clauses will be similar in different databases. So that's what it's, I mean, there is a standard, there is a standard institute which maintains those kind of SQL statements. 1 minute. Okay. Coming to the different categories of SQL statements. These are the different categories of SQL statements, but there are chances that you may find different information also. Again, like these particular categories are based on Oracle database. Okay. And the SQL statement categories, they are defined in nothing but like we have a set of commands, right? Like a create command, alter command, or whatever the command which take the from clause, where clause. They are they are bifurcated in different categories: data definition statements, data manipulation statements, transaction control statements, session control statements, and system control statements, and embedded SQL statements. So what exactly these categories are? Nothing but like if you consider our normal statements like insert command or insert clause or select clause, or your what you say the alter clause, these particular commands, they are defined into specific category, because the specific category will have its own functionality. If you say data definition stuff, it will automatically perform its commit operation. It's auto commit operation. When you say data manipulation, it is not auto commit. You need to have you need to explicitly commit the operation, nothing but explicitly commit the transaction. So I'll show a list of generally used SQL commands. I mean the statement which come on different categories. If you consider this data definition language, so your create, alter, and drop, everything, they come under your data definition stuff. Because if you create an object, automatically the commit operation is done. We did not predefine, you did not explicitly write a commit operation for that. Okay, grant operation, purge, rename. I know everything comes under part of your data definition stuff. The only thing is, when you say data definition DDL stuff, it is used to define an object in the database. It can be of any object, nothing but when you say an object in the database, the object is nothing but your table, view, synonym. There are many other things, triggers. They are all objects. So whenever you're defining or whenever you're altering, whenever you're dropping, everything is a data definition stuff. Clear?
Yeah.
Coming to data manipulation stuff. So when you say data manipulation, nothing but we are updating some data in the database. So using your SQL commands, you are updating the database data. So that is why the statements which perform this kind of operation, they come under data manipulation language. And most generally used data manipulation language statements are insert, update, and delete. Most of the times we use these kind of things, and of course merge also used. And the remaining things, we use it very rarely. And coming to the select statement, select statements also comes under DML statement, because even though even though using select statement we cannot update any data in the database, but while showing the data on the output, we can manipulate the data and we'll show it, right? It's only for the user purpose we can manipulate and show it, but we cannot commit any information into the database. So that's why even the select statements also comes under data manipulation language according to Oracle. Okay, clear?
Yeah, clear.
Yeah, I mean, you guys are on mute or what?
Hello? Can you hear me?
Hi, Sridhar. Actually, I'm not.
Yeah, actually, sorry, Monica, tell me.
Yeah, I got it. Actually, recording option I was not getting. Now I.
Yeah, I enabled the option now. Yeah, so you guys are getting right what exactly DDL and DML stuff?
Yes.
Yeah, just ping me, like if you have any doubts, because I'm just going in normal fashion. So just want to know your updates also while giving the data. Okay. So coming to the transaction control statements, yeah, coming to transaction control statements, it will, it will commit to transaction. Nothing but, what do you mean by transaction? A transaction is nothing but a statement which you give to the database, performing some operation on your database data. That is called transaction. It can be a retrieval of data, it can be updatable of data, it can be inserting of data, whatever it is called. So we will have some transaction control statement, nothing but a commit, which will update a particular transaction. So what exactly commit does is nothing but the data which is there in the cache of your database, it will get updated in the database permanently. So that's how commit does. And rollback is quite opposite to commit. So what rollback will do is it will get back the committed data. So that's what rollback does. Save point is nothing but like you have a set of transactions and you want to maintain each particular transaction in a particular save point. So using your commit, you can mention the save point to which particular save point you want to save the data. Those things comes under your that's part of your save point. We'll deal these kind of things like once we come across during our procedure language stuff, PL SQL stuff. As of now, what you need to understand is like which particular command comes under which particular control statements. So the main things are data definition language and data manipulation language. They are very much important stuff. Okay. Yeah, session control statements, it controls your session. Nothing but what do you mean by a session? So whenever you connect to your database using a particular user, a session is maintained in the database. Let me show you that one of the table where you'll have that information. Connect to the system schema. If you type it, if you just mention this $session, so this particular metadata table will store the information of your all sessions which are present. What I mean by session is nothing but whenever you connect to the database, a session is maintained between the end user and your database, because you need to maintain the transaction, right? Because it need to know from which user the database should understand from which user it is getting the commands. So what information it need to send to the user, isn't it? So for that purpose, you will maintain a session. If you consider your browser language stuff, you'll have a cookies, right? Why we use cookies in the browser stuff? In any of your browser, if you understand, like most of the what is the language here? Okay, they will maintain cookies, right? It's for the maintaining of session purpose. So here also the database maintains a session, and using this we can identify which user is active now and who is logged in from which particular system they logged in, and everything we can find out. See, if you want to find out, we can find out. Status is active, and there should be someone, and even it will tell the system name also here. Machine name is here, this one. From which machine also it is saying to me. So this is your machine name is nothing but a computer name, right? The computer name which is present in your My Computer properties. Here. Somewhere it will be right, computer name. Somewhere, yeah, this one, full computer name, right? And work group name, MS Home, and this one. Okay. So this is my system name now. Yeah. So other kind of statements like system control statements and embedded SQL statements. 1 minute, sorry. So different kinds of statement, nothing but system control statement. This for maintaining your nothing but while running the alter system command. That comes under your system control statement. And embedded SQL statements, nothing but there are some statements which you can write in your PL SQL, nothing but dynamic SQL part. That comes under embedded SQL statements. So we have something called dynamic SQL. There we can insert all your create commands and everything. We have execute command. In that we will mention your SQL statement there. That comes under your embedded SQL statement. That will lead later in the PL SQL part again. That part is called dynamic SQL. Yeah, coming to the joins. Yep. So before going to joins, let us understand why we go for a joins. The only reason for going to joins is, yeah, okay, before that, one more thing. See, I think I have mentioned you already that in a database you'll have multiple objects, right? Multiple tables. So why we use multiple tables is nothing but your, as we aware that most of the database which we use in real world, they are called relational database. Why we use database? I mean, the database which we use called relational database, nothing but like we store the information in a relation way. If we consider our employee schema and department schema, so all the employee data we are storing in the employees table and department data in the department table. We are not repeating any data anywhere because we are following the normal forms, which says that we should not repeat data. Nothing but you should not store any redundant data. The only information in the employees table we are storing is only department ID, and any department information. What are the department information? We are storing in the departments table, right? So we have a relation between employees and department. Nothing but using department ID's relationship between different departments. So in real world also, like if I tell you one more example, like if you say, okay, I'll come up with some example like your purchase invoice, right? So whenever you buy any goods from any of your local vendor, nothing but a supermarket, okay, they'll give a particular invoice, right? That we call it as a, for you it becomes a purchase invoice, but for the vendor it's a sales invoice for him because he's performing some sales order for him, right? So let's consider in any way we can consider. Let's consider that's a purchase invoice for you. It becomes a purchase invoice for you, and it becomes a sales invoice for the vendor. Why like that is because when he says sales, he's getting income. The vendor is getting income, right? And for you, you're spending cash. That's called purchase operation. Okay. Why I'm telling all this is because we have some relationship in this particular bill. Why? Because so any of your invoice will have header information, lines information, right? Header information, lines information. In the header information, if you see any invoice will have a invoice number and a date and some the billing authority or the bill person, something etc. other information, right? After that you'll have a lines. So what I mean by lines is nothing but for each header you'll have multiple lines, nothing but all the goods which you purchase, nothing but you'll have a quantity information, the item name, the price, etc. Right? So for each header you'll have multiple lines. The relationship between header and lines is one-to-many stuff, because for a single header, nothing but in a single bill you can have either one line or a multiple lines. That is it's a relationship between header and lines is a multiple, nothing but it's a one-to-many relationship. So coming to the employees and department, it is also same stuff again. For each department you can have multiple employees. This also again one-to-many relationship, or I can say one-to-star or whatever it is. Okay. So that's why in any general word, if you take any real world example, always there's a relationship between different entities, different objects. And one more thing is you never want to duplicate the data, because the duplicating of data is again lead to many problems. The data which is stored in the database should be on you'll have only single truth, not multiple truths, right? Because if your data is stored in multiple tables and each table is having different data, you cannot understand which data is perfect, which data is a reliable one, right? That's why first thing is data should not be duplicated, and if needs to be duplicated, nothing but if at all if any particular table is reference to another table, it should store only its primary key. In our example of employee and departments, we are storing only department ID in the employee table, because if any updates to department table will never affect any employee table, because department ID will generally never be deleted. Maybe department name can be changed or manager name can be changed, right? So if you change any department name or manager name, it doesn't affect any employee table, because in the employee table we are storing only department ID. So that is why this is one of the reasons why we go for the different tables based on your data stuff. You always bifurcate into different tables and mention the relationship between different tables. Okay. Yeah, so coming to the joins, okay, why we use joins? Now we understand the concepts, right? Like because in a single table you can never store data. In a single table you can never store data. That's why we always go with the multiple tables, and that's why we need to use joins. So coming to joins comes into the picture whenever you are using multiple tables. So a join is a query that combines rows from two or more tables, views or materialized views. So Oracle performs a join whenever multiple tables appears in the from clause, in the queries from clause. A queries select list can select any column from any of these tables, because joins comes into picture when you're using data, when you are retrieving data from multiple tables. So if any of these two tables have a same column name, you must qualify all references to these columns throughout the query with table name and to avoid ambiguity. Nothing but what it is saying is, if you consider your employees table and department table, the common column in both tables is department ID. So if you are displaying the data from multiple tables, you should make sure that you should have an alias for the table name, and you should specify the alias name dot column name, because else it will lead to an ambiguity. I'll show that example now. So here, select okay, this for employees. Department. Okay. What I will do is I'll give as D for this, I will give as E for this one, and now so here if you consider how many rows it is fetching, 3100 right rows, right? So we already aware that we does not have this kind of data, right? We just have around 108 employees. We just have around 111 employees. And how many departments? 28 rows. I think I showed you this one example some time back. Let me triple one. Okay, this is the reason is your Oracle automatically performed a join on this one. We just mentioned multiple tables here. We did not specifically mention any where condition here. So that's why Oracle automatically calculated some its internal way of dealing with the data and displayed all the data here. Okay, here the example here is if I want to display department ID. So if I just write display department ID, it will give an error because department ID is present in both tables. So here, column ambiguously defined. That's why we are getting this kind of error, because when you say department ID, we should mention which particular table you want to, from which particular table you want to retrieve the data. Mention E dot department ID, it won't give an error. But if you come to first name, because first name is there only in the employee table, so it doesn't require any problem. It does not face any issues even if you give directly. I just mentioned first name because the first name is not present in the department, so it won't give any problem to the database. It will automatically finds that this name is only present in a specific table, so it won't lead to any issues. Okay. So now coming to the joins, there are different types of joins, and which joins we should use and what basis we should use, and yeah, we'll deal that. So there are different joins types are inner join, outer join, self join, cross join, and the other stuff is joining using multiple tables. So coming to the inner join, yep, inner join comes into the picture whenever you are performing data on the same table. So you'll just use a comparison operator. The only operation which you use for the inner join is the comparison operator. That we call as an equijoin. See here, equijoin is join with condition containing an equality operator. Nothing but you're assuming that always the data exists in multiple tables. Nothing but data always exists in. See, if you consider your department and employee table, we always consider that every department will have an employee, whether it can be one-to-one relationship or one-to-many relationship. So whenever you have data in that fashion, you can go for the equijoin. It is a join condition containing an equality operator. An equal join combines rows that have an equivalent values for the specified column. So what exactly this is that if you consider our employee and department table, we have just mentioned a from clause, and after that I did not mention any where clause here. But we know that there is a relationship between two tables. One is department ID is the main. There is only one relationship, that is the department ID between your employees table and department ID. So if you mention that, it will filter out the data which is specific to this where condition. Let us write one that equijoin now. Where? So what is the condition we need to write? Here E dot department ID is equal to D dot department ID. So now if you see the data here, okay, I'll display all the data. How many rows it is displaying now? It is displaying only 107 rows, right? So now, of course, we have some, if you consider our employees table, we have around 111 rows, right? Again, 4 rows were skipped. Okay, so I'll tell you the reason why it was skipped also. If we consider employees table, there are 4 employees who does not have department ID. So that's why it was not filtering that particular data, where department ID is null. So there are 4 employees who does not have department ID. See here. That's why this particular condition, this, as we have an equal condition, if you remember our equal to operation on the null operation, so whenever it matches, only this particular data will be written, right? If it is null, it is not equal. This here we have a null operation, and it is not equal to some department ID which is there in the department table. So that's why it is not filtering those data. Nothing but it's not getting that data, right? So if you want to retrieve that data, we need to use what you say, the outer join stuff. We'll see that later part now. We'll concentrate on the equi-join now. So this is how we perform the equi-join. We just mention an equal to condition between the different tables which we are using. If you have another table, just you can mention that particular condition again. So you can use n number of tables in the front clause. It's not specific to only 2 tables. You can have multiple tables on the condition. Okay. So I think I have one more example on that. Yeah, yes, here. Okay, let me run this one. So there is a table called jobs, okay, and if you consider this particular table, locations, countries, and regions. There are 3 tables, so we are considering with all these stuff now. So in the location, if you consider this location, in the location table we have information called city, country ID, and location ID. So the location ID is the primary key in the locations table, okay, and the country ID is a reference key. Nothing but like the department ID is the reference in the employees table, right? The same way here also, we have the table called locations, and in that we have a country ID that refers to the foreign key which is there in the countries table. If you see this countries table, you can have the country ID and the country name. So here country ID is a primary key here. The country ID is a primary key in the countries table. Again, we will have the information called region ID. This region ID is a foreign key which is stored in the regions table. So if I want to perform a join between 2 tables, I can mention that, because in the locations table we have a country ID, and that country ID is a primary key here, right? So this is joins between 2 tables, because I want to display the information of country name for a specific location, right? So that's why I'm joining these 2 tables to get that information. Because if you consider this one here, Roma IT, location ID, I'm getting the country ID one and the country name. Okay, but if you have a requirement saying that if you want to get region name also, I need to join 3 tables, right? So how I'm doing that is, first thing is I've taken 3 tables in my from class: location, countries, and regions. Okay, we are aware that the locations, the relationship between the locations and countries is country ID, and the relationship between the countries and regions is region ID. So that's why we mentioned 2 conditions here. If it does not, if you don't mention these 2 conditions here, you will get the different data. You won't get the proper data. See here, if you see this one, the city, country ID, country name, and the region name. Okay, so this is how we can join with the multiple tables also. So this is all equal join, because you're all having only equal to operator. This is called equal join. So any dots in this one?
No, nothing right now. Till now is fine.
Yeah, any dots?
No,
No.
it's good. It's good. You can.
Fine. If you have any doubts, you can ask me, because the other join will be quite complex stuff. So in the inner join, we have equi-join, natural join, and cross join, right? So equi-join is nothing but only equal to operator, And natural join is nothing but automatically your Oracle will perform the natural join operation if you give a natural join keyword. A natural join offers a further specialization of equi-joins. The join predication arises implicitly by comparing all columns in both tables that have the same column name. So nothing but if you just mention natural join between this particular tables, automatically what are the columns are same, it will perform the join operation automatically. So automatically Oracle perform the join operation and retrieve the data. So this is an example of natural join. So most of the times we will be using equi-join. That is most of the times we use that one. So coming to the cross join, nothing but you are joining the tables without mentioning any where condition. That's similar to the cross join keyword, because there are multiple ways of writing the query. So either you can give the keyword here, or either you can skip the condition which you are mentioning that. So this is nothing but this is equivalent to. So how many rows we are getting now? 100 rows. Okay. So this is equivalent to this one. Select star from EMP comma DPT. This again a cross join. Okay. So you can write the cross join both ways. Either you can just skip the condition, that's again becomes a cross join, or either you can mention the keyword cross join between the tables. Okay. We never use this cross join because it will repeat the data, right? And it's again a big problem. So we never use this cross join. So it's very rare case. Yeah. So coming to non-equi-join, the only difference between equi-join and non-equi-join is nothing but the condition which we mentioned. That becomes other than equal to operator, which if you use any operator other than the equal to, that becomes part of your non-equi-join. Yeah. So coming to the self-join, nothing but like performing the join operation on the same table. If you consider this example here, okay. Before that, let me show you one more thing here. So every employee is having a department, and apart from that, every employee is also having a manager, right? So while displaying the data, if you want to display the manager name, so how to join that? So that's what I need to get the employee name from this particular table itself, right? So that's why I need to perform join operation on the same table. So nothing but when you perform a join on the same table twice, that is called self join. So what I'm doing here is like I have taken two aliases for the EMP table. One is employee E and employee manager M.
Sridhar,
Okay, what I'm doing here is every employee will have employee number, right? This should be MGR. It's not employee. This should be MGR, because this manager should be equivalent to employee number, right? See here. What I will do is order by ME name. Yeah. See the black. There are 5% who are working under black. There are 3 persons who are working under 4. Okay. So this is how we can retrieve the data from the same table twice. Okay. If you want to retrieve all the columns of E, you can just mention E dot star like this. Here. These are 5 persons who are working under black, and there are 3 persons who are under working 4. This way we can retrieve data from same table twice. Okay. So whenever you're performing any join, you should make sure that on which particular column you want to perform the join. That we should know it from your business, because like if you consider employee table, as we are aware that employee will have a manager and that information is stored in the same table. So that's why we are able to join in the same table. But if you're having a database, if you're having a requirement saying that your manager information is stored in another table, you may need to join the different tables, right? That becomes equi-join. But if we are joining the same table twice, that's why we are calling it as self-join. So this particular self join comes into picture. Even if you want to write a hierarchical queries, we'll be using this kind of condition. That we have a concept called hierarchical queries, where it will show the data in a tree structure. If you consider a tree, we'll have a the top level you have a tree node, the top level tree node. After that you'll have a left child and right child. Again, the left child may have n number of childs, the right child may have n number of childs, right? It will show the data in a hierarchical fashion. So for that purpose, we have a number of the functionals which are provided by Oracle. Using that, we can achieve the hierarchical data. Yeah, so coming to the outer join, this outer join comes into picture whenever you're performing same thing, nothing but whenever you're joining multiple tables, but whenever there is a chance of deficiency of data in one of the table. So that's why your outer join comes into picture. If we just now saw one of the example here, we have some deficiency of information in one of the table, right? Because we are able to get only 107 rows, right? But even though we have around 111 rows, right? The employee table is having how many rows? It is having around 111 rows, but we are able to retrieve only 107 rows because the reason is that there are some departments who does not have any department ID. So that's why our equal to operation is getting failed. There are 4 employees who are not having department ID. That's why this particular query is getting failed. But if you want to display all the employee information irrespective of department ID, so we need to go with a different kind of join. We'll see what that kind of join is. So your outer join extends the results of a simple join. Outer join returns all the rows, and that satisfies join condition also returns the rows from one table for which no rows from the other satisfy the condition. What it is saying is that, so when you perform an outer join, it will return all the rows irrespective of the satisfaction of the condition. Nothing but if you consider this particular condition, here it is we are getting only the rows which are satisfying the condition. But if you consider outer join, it will retrieve all the employees rows irrespective of this condition, whether it is satisfying the condition or not. It will return all the data, but not in all the cases. It will filter the data first, and after that it will return all the data, even though there is no relationship between the department ID of employee with the department ID of department. We'll see that how to write a query in the outer join. We'll see. So there are 2 types of joins, left outer join and right outer join. Here left outer join says that, see here, a left outer join uses the ANSI left outer join syntax or a plus operator to all the columns of B in the join condition. For example, if you want to retrieve all the rows of A, what you need to mention is you need to mention the plus symbol on the other side. In this example, what we are doing here, where employee.department ID is equal to department.department ID plus symbol. So why we mention the plus symbol here is because we have some department ID in the employee table where they are null, and we want to retrieve that particular data also. That's why we are placing the plus symbol on this one, saying that whenever you get some department ID which is not matching with the department ID of department, please retrieve that data also. Don't perform the condition. That's what we are saying here. If I mention plus symbol, it will retrieve all the data for me now. 111 rows. Okay. Yeah, any doubts in this?
No.
Are you able to follow or what?
Yeah.
Hello?
Hello, Sridhar.
Can anyone speak?
Hello.
Hello?
Sridhar?
I could not hear you actually. Hello? Hello? I could not hear you. I don't know exactly the reason. No, I could not hear you. Did you kept on mute or what? Can you check your phone? I mean,
No, we are not on mute.
okay, fine. Now I'm able to hear now.
Okay.
Yeah, that's fine. So are you able to get the information which I'm trying to say?
Yeah.
The outer
Yes.
join, the equi-join, or any black and white stuff?
It's quite confusing, but we are getting it.
Yeah, that's what. Yeah, The only thing is, like whenever you are performing any joins, I should make sure that on which particular column you want to find the join. And one more thing is, you need to find out whether there is a one-to-one relationship between both tables, or there is existence of one data without the existence of another one. If you consider employees and department, I can have an employee without having a department ID also. Because this kind of information you need to find out. Whenever you're writing a query, you should find out whether there is an existence of one particular data without existence of another data. This is one important thing. Because here, if you
Can you
consider
repeat
employees,
again? Sridhar.
sure. Yeah, sure. I'll explain that. So let's consider the employees and department table now. So what I'm trying to say is, I can have an employee. We can have an employee without department, right? So that's why your outer join comes into picture. But if you consider one more example, headers and lines, the relationship between headers and lines is always header ID. Header ID is the primary key here, and header ID is a foreign key here. Of course, the line ID is a primary key here again. But here the relationship between these lines and headers is always always a line will have a header ID. There is always a one-to-many relationship between, compulsory it will exist. But here, if you consider the top example here, there are chances that you can have an employee without having a department. So even you can have a department without having employees under it, right? So that is what this particular says. So whenever you are joining the data, first thing is you need to find out what is the key you need to join, and whether you should go for inner join or outer join. So outer join comes into picture when there is a deficiency of information. So outer join is used whenever you have a deficiency of information. What do you mean by that is, there is an existence of one particular data without existence of another data. The same thing, the employees and department example. Clear?
Yes.
Yeah, so this left outer join says that if you want to filter all the data irrespective of the join condition, then you can mention the left outer join condition. So the other way is, the other one is right outer join. If you consider this example here, we are having a condition on the other side. See here, for left outer join, we are mentioning the condition on this one. Nothing but, you want to filter the data of all employees. I want to get all employees data irrespective of that particular employees having either department or not, isn't it? See here, what I'm doing is, I want to get all the data of employee irrespective of that particular employee whether he's having department or not. Okay, what is the mistake here? Department underscore ID. So one more thing, there are chances that the
I think
the data,
employee.
yeah, as employees and departments. Okay, yeah, here departments, employees. Yeah. So now we got 111 rows, right? Without mentioning this plus condition, we could not get that particular data. This is an example of left outer join. Why I'm calling this as left outer join? Because I was able to display the data from this particular table. We are having two tables, right? This left table and this right table. So we are able to retrieve the data from left table to completely without having any failure, right? So that's why you're calling as a left outer join. So for the left outer join, you should have the plus condition on the other way. I think with the other side. Okay. So right outer join is just quite opposite to left outer join. So coming to right outer join here, if you see here employees and department, so what we have, okay, instead of this one I'll just copy from here itself. See here, this left outer join, and here this example is right outer join. So right outer join says that I want to retrieve the data from total department table irrespective of the join. So you should have this one, this condition should not be here, it should be here. Okay, Maybe it is so confusing for you. So now we got 124 rows. I'll see the reason for that. Just give me 1 minute. First thing is we need to find out how many departments are there. Okay. How many are there? 28. Okay. For each department, we have a relation. What is the relation between your department and employees? It is 1 to many. Okay. And apart from that one, how many departments are there in your employees? Distinct department ID for employees. How many are there? 12 rows. Okay. So there are only 12 rows. Sorry, only 11 because there is one null, right? There is one null operation. These are the set of departments which are present in your employee table, but we have it is displaying 12, right? There is one null department, so this is not a valuable department. So only 11 departments are there. Okay, but in the departments table we have 28 rows. So there are 17 departments which are not available in the employees table. Okay. So while performing the right outer join, what I need to display, I want to display all the departments irrespective of whether that particular department is having employees or not, right? So that is a requirement here. So what I want to display here is departments dot department underscore ID, comma, employees dot employee ID. Okay. So I want to display all the departments irrespective of whether that particular department is having employees or not. Okay. If you consider, okay, one more thing, I will order it based on the department ID. Here it is displaying 10, 20, 30, 40, okay, 50, 80 also. After that 100. First thing is we need to find out this list here, then we can have this. I will copy this information here. Okay, so we have these set of departments, right? And if you observe here, so there are some missing departments will be there. After 50, what are the departments here? 50 is there, 60, okay, 60, 70, 80, 90 is also there, 100, 140, 160, 170, 180, yeah, 190, 200, 210, 220. Yeah, see here. One minute. One more thing I want to show you. Employees that. Okay. If you consider this one here, see here, we are able to display all the department information here. Department ID, department name is there, but we does not have any employees with that particular department 120. Because if we consider our distinct department stuff, where is this distinct department stuff? This was right. We have only 11 departments. I copied wrongly actually. Order by department ID will give it. Yeah, this is a correct one. It seems quite confusing, but you know, like, let me carefully try to explain to you. See, first thing is what I have done is I am finding out all the distinct departments which are there in the employees table. There are only 11 departments. Okay, and one more thing is if I perform an outer join, nothing but you know I am performing the right outer join here on the department table, because I want to display all the departments irrespective of whether that particular department is having employees or not. This other way around. This is a right outer join, not a left outer join. This is a right outer join. Displaying all the departments irrespective of if it is having employees or not. Okay. Here, if I execute this particular query, if I don't mention this one, we'll get a different data. Nothing but your 3,000 rows will get it. If I mention this particular query here, I will get only a few rows. That is 124 rows. So I'm trying to validate how I'm getting 124 rows. Okay. So, but if in the left outer join, the above example, we are able to fetch all employee data, right? That was only 111 rows, isn't it? This example here, it's only which row join this one? This left outer join. We are able to fetch only 111 rows because there were plus condition on the other side, and we are able to fetch 111 rows. But if I mention the plus symbol on this particular side, nothing but the left side, it's our right outer join. See, for right, you will have a plus symbol on the other side. That's quite opposite. When you say right outer join, you'll have a plus symbol on the left side. When you say left outer join, you'll have the plus symbol on the right side. Okay. Here we are able to get 124 rows. Okay. Yeah. So after 110, we does not have any employees with the employee ID because there is no existence of any employee with this particular department, right? So that's why after 107, if you observe this one, how many rows are there after 107? After 107, like we have around 17 rows. Okay, there are 17 departments which are existing without having any department ID. Okay. So total 117 rows. We are having how many rows? Total in the employees, we are having only 111 employees, isn't it? And now if you we found out that there are 17 departments without employees. Okay. And after that, one more thing is, okay, where is that here? And from this, we found out how many rows here? This was 11 departments, right? Okay, 1 minute. So for each department, it will list out the employees under it. So this is 10 department 10, and will list out the employees under it. Again, the same way it will go around. See here, this particular department is having, it will display all the employees under it, and after that the same stuff follows. And there are some departments which does not have any department ID for them. So for this purpose, for this one, what we are storing, we are just storing null here. If you don't mention this condition, this will fail. See here, I'll just remove this one and like execute it. So we won't see that information now again. See here, after 110, there's no data at all. If I mention this plus condition, I was able to see all the departments because we have around how many departments? We have around 28 departments, but there is only 11 departments. There are only 11 departments with employees, and there are 17 departments without employees. But if you want to see that information also, because in generally charts, okay, I'll give one more example. There is the sales data. Let's consider there is a sales data, and each sales data again will store in multiple tables, right? If you want to list out all the employees, whether it is having some sales transaction or not, so we can go with these kind of joins. Because if you consider any sales related data, always what information, nothing but sales executive information is personal information. Everything is stored in this personal information table, and your sales transaction, that will be stored in the sales transaction table. Okay. If you want to list out personal information plus sales transaction table, so what we need to do, we need to perform some outer join here, because I want to list out all the sales executive irrespective of whether he's having sales transaction or not, right? So that's why here this kind of joins comes into picture. Okay. So full outer join is nothing but the combination union of your left outer join and right outer join. So Cartesian product is nothing but, like whenever you're joining two tables without mentioning the where condition. So it will multiply the rows and it will display all the data. For each row of a specific table, it will list out all the tables. Nothing but the first example which you have seen. This one. Where is that? Yeah, this one. If you see this here, for each department ID, okay, I think, do we have here? Okay. I will just mention order one. So for each row of department ID, what I will do is I will display employee department information here. How many? 28. You see, this total data is repeated again. This total employee data is repeated for each and every row of department. So this way we'll get multiple data. So the Cartesian, we never use Cartesian join actually. In the real world, we never use that one. Okay. Yeah, coming to the cursors, yeah, I'll stop here. So try to practice on this one, then you'll get it actually. If you have any doubts, you can send me the thing. So even you can perform the same multiple joins. You can perform the multiple. We can have, there is no limit to the number of the number of tables which you mentioned, the from clause. Most of the times in the real world, we've been having around 5 to 6 kind of joins. So if the query is complex, what most of the times we do is like we create it as a view actually. That we'll see in the later sessions. So if your query is so complex, what we'll do is there is chances of developer making mistakes, right? So not to disturb that one, what we do is we'll create a view on that. Okay. Yeah. So tomorrow we'll start with the what is the other session? I'll come up with that tomorrow. What I'm going to start? Not yet decided. Yeah. So anything more?
Sridhar, the tables you're working on, right? So can we get those tables as well?
Yeah, sure. I mean, don't you have the HR schema?
No, I don't have it. No, I don't have it. Like, where did you get those? Like,
hello?
hello, Sridhar. Hello?
Yeah.
Yeah. Where can we get those?
1 minute, sorry. See, we'll have the file. We can get that file actually. I can send you the file if you want.
Okay, that would be great. Yeah.
So which particular database you're using? Are you using XC database or Oracle Standard Edition? Which one you are using?
Oracle Standard Edition.
So then you should have the HR schema, right? You will be having the HR schema in your system itself.
Okay.
So what you do is try to connect to the system using HR schema. Then you'll get the data. So yeah, if you face any issues, you can come back.
Okay, sure.
What you can do is you can find out whether your system is having HR schema or not. Just try out this one. Select start from all_users. Okay. So write this query and find out whether HR is present or not. If HR is not present, then it says that your HR schema is not there. Using this, you can find out.
Okay.
Okay.
Thank you.
If it is not there, just mail me. I'll send the HR schema.
Sure.
Yeah. Okay.
And
So-
one last thing.
Yeah,
if,
sure.
If like they miss a class, is there an option like,
Mm-hmm.
so if I have some work and I was not able to attend a class, like what is the alternative for that?
I mean, yeah, generally we used to go, okay, there are chances that, if we want, we'll try. We can have a separate, like we can have some. I can have some, like a 30-minute session before our original session. Then we can, what you say,
Oh.
we can get that data like that. If it is important, I can cover in that way. But if it is not important, yeah, I'll just send out your recorded session or the slides. You can practice on that.
Okay.
If it is important, of course, I will take care of that. I'll try to cover that.
Okay.
Okay.
Thank you very much, Sridhar.
Yeah. Okay. Yeah. Thanks all. Bye.